Here we have a question. In this question, we have to determine the distance x when the ray from source returning to the source after reflecting from the convex mirror and then from the concave mirror. And also we have to find the distance x when the ray from the source returning to the source after reflecting first from the concave mirror and then from the convex mirror. So let's understand what's going to happen here. This is the concave mirror and this is convex mirror. So here in the first condition, the source is pointing light to the convex mirror and the image in the convex mirror is being the object for this concave mirror. And after that, it is saying that the image of the concave mirror is coming back to the source. And for the second condition, it's telling that first the concave mirror is reflecting the image and that image reflected by the concave mirror is being the object for convex mirror and the image of convex mirror is directly pointed towards source back. So here in this both conditions, as the mirrors follow reverse law, the distance x would be same. So let's find the distance x, where we will use the formula where we can find 1 by v plus 1 by u is equal to 2r. This is the formula where v is the distance of image, u is the distance of object, and r is the radius of curvature of the given mirror. So for the convex mirror, this distance would be, as this distance is x, so this distance would be l minus x, and it is in the opposite direction of the radius of curvature, so it will be minus, as we can see here. So from here we can find the object's image, that is v1, as we can see here. Now we have found the object's image. Now this image is going to be as object for the concave mirror. So for the concave mirror, as we can see, we will write the formula 1 by v plus 1 by u is equal to 2 divided by r. Now here we can see r is negative and also the image is at s distance from the arc, so it's also negative. And let's suppose at this distance L is the distance where we have got the V1 is the distance where we have got the image from the convex mirror. So this would be the total distance, that would be V1 plus L, and that's also negative. So from here we can find the value of x. Now we have found the value of x in quadratic equation form. As we solve the quadratic equation, we can find that the value of x is equal to 0.24 meter or 1.05 meter. Since the distance x lies between the two lenses and the separation between them is 0.60 meter, so we can say that the distance x is equal to 0.24 meter. And as we discussed, this both mirror follow the reverse law, since the concave mirror and convex mirror follow the law of reversibility of light. Therefore the change in direction of the source light does not change the path deflected light. So the light traces the same path as the solution in part A. So we can say that this distance x would be same for both of them. This is equal to 0.24 meter. Thank you.